Hi, this is Mark Tucker.
Hey, this is Allen Firstenberg, and together we are Two Voice Devs.
Two voice devs.
Two Voice Dev. No, that was last year's
Yeah, that was.
Christmas.
Sorry, I don't know why I was thinking about that. Maybe
It's
there,
getting. I don't know about there, but it's getting cold here. So Christmas easily leaps to mind. I can appreciate that. We're
yeah,
we're
so
recording
we
this. We're recording this in November now, so it's
so
fair.
yeah, there in the evenings there is a chill in the air and it is a brisk 82 degrees right now.
Right. It is a brisk 40 degrees Fahrenheit here. So ah, don't ask me why I live in New York. Anyway. Um, so how are you doing, Mark? What's been up there?
Well, something that's interesting, I think that you would be interested in talking with me about, and others might be interested. It's kind of a news item plus some technology discussion. Um,
News and tech I can deal with. Okay.
yeah. So we've talked about before various times, or at least mentioned VoiceFlow as a company and their product. And something came out recently. Somebody brought it to my attention. They had some questions about changes that were going to affect the Alexa skills that they have developed with VoiceFlow and hosted with VoiceFlow.
Okay.
Um, but
So
so there's going to be some changes there, and that impacts how that's going to go forward.
okay, interesting. So let's kind of review what VoiceFlow is. I mean, or what it started as.
Yeah,
I think we kind of got interested in it because they were a great, mostly design tool was kind of how it seemed like for designing Alexa skills and eventually Google Assistant actions.
right.
And it was very much a visual design tool. So you were creating these conversation flows literally
Yep.
using kind of spreadsheet like tools. And you could say, here's where you wait for input, and here's how you process it, and here's where you do output with it, and so forth and so
Right.
on. And that's kind of how they started out. But they've grown over time, and they've
Yes.
grown a lot over time. They're doing fantastic now. Eventually, they started taking on chatbot roles in general, not just the two specific ones. And within the past 9 months, like
Yeah.
everybody else, they've started bringing in more and more generative AI stuff. So now you can create knowledge bases that through VoiceFlow people can ask questions about, and it'll use generative AI to respond with them, or create generative AI responses based on inputs. So it's gotten a little more flexible. It's shifting its focus a bit, I would say.
Yeah.
So
Yeah.
that so what are the nature of these changes?
For a number of years, you've been able to, inside of VoiceFlow, lay out your blocks and your lines and connect to create an experience. And you've been able to then connect VoiceFlow to the Alexa Developers Console, and in essence, push changes um, that need to go to the Alexa Developer Console. So there was an integration inside of VoiceFlow to Alexa, as well as being able to host your skills right there in VoiceFlow. And so it was a design tool. It was like a low code, no code tool to create skills. It allowed you to deploy and host, and you were able to kind of do it all there. So a lot of the pain points of creating things or the skills and figuring out where you're going to host it and stuff were just taken care of
Mhm.
by having it all tightly integrated with VoiceFlow. So the way that it has changed recently is that that tight integration is gone. I think
Hmm.
they've got some wording around that they'll maintain existing experiences, but if you're looking to use the tool in the future to do things like Alexa skills, you can do that, um, because they're kind of going more towards this um, designer, and then it will host that logic and a kind of a runtime, an API, so to speak, that you could then run your bot. So basically it's bot logic as a service is kind of how I think about it. Which is like the core piece of your bot. It's the functionality that you have in the designer. You can have intents, you can have flows, you can have output, all that stuff is going on, and you can have that all as a service, but then you've got to figure out the integration yourself, in essence. So
in many ways, this is similar to what Dialogflow has done for years.
mm-hmm.
There are differences, and we'll discuss the differences in a minute, I'm sure. But the similarities are you've got all of the logic processing, at least some of the business logic in this the VoiceFlow or the Dialogflow layer, and Dialogflow refers to these as integrations. So there was a kind of front end that you could kind of interchange in some ways. You could have a Slack Messenger front end, and Dialogflow had their own chat web-based thing
mm-hmm.
front end. And of course, once upon a time, there was a Google Assistant front end, and you could mix and match these as the front end to the Dialogflow logic, which was mostly front end independent. Is that kind of how it's working?
Yeah, that sounds similar. So it sounds like Dialogflow called them integrations.
Yeah.
Like Microsoft probably would call them channels. There's lots of different, Jovo has kind of a similar concept. They call them platforms. But the idea is that for all those different types of clients, you need some sort of a server piece, unless you're writing like a heavy client. But there's typically a server piece that needs to be hosted someplace. And like in the case of Alexa, probably the easiest thing to do would be to host it in AWS Lambda, do a Lambda function. But the connection from the Alexa service to the Lambda function is kind of a connector called the Alexa Skills Kit. Or you could choose to say, I want to host this on my own website or as a Docker container hosted someplace. And then maybe that connectivity layer is something like Express.js. So there's a kind of a server piece, there's the actual hosting piece, and kind of the connector that sends the thing to where the logic is. So there's some kind of, it's still a lot of backend, mostly in the back end, but it's this layer that kind of fits in between the client and the Dialog API from VoiceFlow.
Okay, so it sounds like they've decoupled that a little bit.
Yeah.
Does this mean you're not going to be able to create new VoiceFlow agents that work with Alexa, though?
So the short answer is no. You can do that, and plus like a whole bunch of other different things, because basically they're saying that's not our focus now. Our focus is hosting this logic of your bot, and all you would need to do is wrap that with some sort of an adapter layer or an integration layer, depending on how you're thinking about it. To connect it with something else, and then you can end to end. In essence, there's going to be something that's hosted that you would have to host, and then there's the actual conversation flow that's being hosted by VoiceFlow, and your backend would have to call that API and handle each of the different turns of the conversation as it goes through. It's there's not a lot of logic that would have to happen in your adapter piece, but there's something that you'd have to do, whereas you wouldn't have to before. The challenge, I guess, is that a lot of that from on the VoiceFlow side before, months ago, was tightly integrated, and you could do a lot of stuff without having to know a lot of tech to host your Alexa skills. Now you're going to need a tech person. You could still have your designer do all of your logic in VoiceFlow and have that part hosted. There's some advantages to that. And because it's kind of like a a tech problem that you have to solve once. You have to figure out, oh, if this is going to be for Alexa skills, then I need to write some code that's going to call this Dialog API from VoiceFlow. But then it's just cookie cuttered after that.
Yeah.
There's nothing, no real logic is going on in that
into that
piece.
thing. It's just an adapter.
But it's a problem you have to solve once but it still has to be solved. And then like, where are you going to host it? So that's kind of like the news from a high level, and then diving into the technical part, kind of what's, here's the problem, so to speak, that has to be solved in order. So, but what's the solution? Well, what are the different options? The different options is that you could, let's say for a second they're focusing on Alexa. We could, it'd be different depending on which channel that we pick. But if we pick Alexa, you have a couple of different options. You can completely roll your own integration layer and host that. And you can choose where to host that. Let's say, since it's Alexa, we're going to do AWS Lambda.
Okay.
So you can write something completely from scratch. You can utilize Alexa Skills Kit, the SDK for JavaScript, and write some code that use some of the parts that it has, and then fill in the gaps with the parts that you need to talk to this Dialog API. You could do that. And you could do the same thing with Jovo. Jovo solves that problem too, and we'll talk about how in just a second. But you could write your own kind of integration for Jovo as well to do that. So what I ended up doing was just looking at the problem again and saying, I think we can solve this problem for a lot of cases, and so I wrote a sample project and a plugin for Jovo that integrates with this Dialog API.
Okay, so basically, you created that integration layer.
Yeah, and so the reason why I chose Jovo is because with Jovo there's a couple different options that you have to host a server. One of them is Express.js, and you'd use that if you were hosting your own API server someplace, like on your own server, or you could wrap it up in a Docker container and host that Docker container someplace. They also have a server integration for Lambda functions. So that code's already part of Jovo. It's just a class that you can include in, and there's samples on how to create Alexa skills using Jovo, and it's kind of starts off at that point. But what the plugin does is then it takes the Jovo request coming in, which could be in multiple different platforms. So it could be Alexa, it could be web chat or whatnot, and converts that into a kind of a more generic input format. And so the plugin takes that input format that's generalized, translates that into a call to the VoiceFlow Dialog API, and then it gets the response back from that API call, translates that into generalized output classes that Jovo already has. So it takes advantage of the generic input output, and then the platform sits on top of that, and there's a translation from the platform specific to the generic input, and from the generalized output to the platform specific output. So then just take advantage of Jovo's capability there to handle multiple different platforms,
which makes a great deal of sense.
Yes.
There's it's basically, it's not just creating that layer for Alexa. It means you've just created that layer for anything that Jovo already supports, which is a bunch of stuff. So that makes that really makes it so that VoiceFlow can talk to a whole bunch of stuff through this Jovo translator, basically.
Right, and what's nice is that you can host the same kind of backend service that's calling your VoiceFlow API that's hosted, and you could even send varying different JSON formats to it, one for Alexa, one for something, a web chat or something like that, and it's able to handle those with a single runtime that's being hosted.
One of the things I found interesting about this was, as I was looking into it, was the VoiceFlow Dialog API. That's actually kind of an interesting API. It's a little different than what most people are used to, which I found fascinating in a lot of ways.
Yeah. So it is it's an API. It's not necessarily REST based because it's actually a stateful endpoint. So part of the URL that you post to is included a user ID. And so it uses that user ID on the back end to allocate some data storage someplace. Not exactly sure where. And so if you think about it, a conversation, multiple turns of the conversation, if you were to follow that along in the VoiceFlow designer as you're testing it out, you can see that it goes to this block and it jumps to this block and jumps to each of those movements is like a kind of a little bookmark of where you are in the conversation flow. And so at a very minimum, then you need to maintain that bookmark across turns to the API. Now, the Jovo code itself is stateless. You have to pass what the user ID is to it, or Alexa will do that for you in the case that we're talking about. So it doesn't necessarily have to keep any state. It's stateless, but the fact that it's using that user ID on the back end, kind of on the VoiceFlow side, to keep track of where you are in a particular conversation and any like variables or things that have to do with what's going on in the conversation flow, then that's how it does it.
No, so it's really interesting that this is a case where it's managing all of the state. It's managing, what's been said, which parameters have been filled in. I think it's a really interesting approach by VoiceFlow to do this, not least of which because it makes developers' lives easier.
Yeah.
We don't have to manage that now. In Alexa, you need to, one of the typical things that we did with Alexa was say, here's a database where we're going to be storing a conversation state and saving it there all the time. You don't need to do that with this. The only thing you need to store is this user ID, which really can be anything.
Yep.
I mean, it's an abstract note. It's more like, I think of it more like a session ID than a user ID, really.
Yeah, because typically when I think about a user ID, I think about saving things across sessions, and I don't necessarily get the feeling that is what it's used for. VoiceFlow is powerful enough that you can call APIs and you can store things. You have integrations with Airtable or spreadsheets or things like that. So if you're, for example, doing a game and you want to keep track of achievements, there is a way to do that. But that state would have to be someplace different. Saving of that state in VoiceFlow, because VoiceFlow primarily, it seems like, is managing that session to kind of keep the consistency and keep your place in the conversation through a given session.
But even so, this is, I mean, it's an interesting approach, and I think creating that front end adapter in Jovo the way you did is going to make it a lot easier for a lot more generic access, because it means that you can say, look, we've already got integrations for this chat system and this chat system and Alexa, it's all there. It's there for you right now.
Yeah,
and that's powerful.
And if you have some other integration that's not there, then you have the ability to write your own plugins to make that integration, and you really only have to worry about the integration into a specific client. The rest of the stuff is taken care of.
Yeah.
And the mapping, I'll go just to like a level deeper. The mapping from how Jovo works to how this API works is actually pretty similar. When Jovo gets a request in, the request can be of various different input types. It could be a text string, like you're typing in a chatbot. Could also be a text string that came from some sort of a speech to text. So text input is one. Another input would be an intent with some optional entities, and that's kind of how Alexa does it. By the time you get the input in from the Alexa service, it's already identified what your intent is and identified any slots that go along with that.
And VoiceFlow can handle being sent just an intent along with some parameters, some slots filled in.
Yes, so the three different input types that VoiceFlow can handle is one called launch, which Jovo has one called launch. It's the thing that happens when you very first start the bot and gives a chance to give back like a welcome message before it starts the conversation. So all I had to do is map that input, the special launch type that was coming in from Jovo to the launch input type, or launch action is what VoiceFlow calls it, and then just pass it in. That worked fine. The second one is if you get text in, then I just pass off that text through a text action type to VoiceFlow. And what happens on that end, when you design something in a designer and you pick like a choice block or define intents, you define what are the different kind of utterances or phrases that would map to that, and then if there's any entities. So you already inside of VoiceFlow define the voice model.
I was going to say, and that's on the VoiceFlow side where you're building an intent system. It's got an NLU as part of it now.
Yeah, so there's a built-in VoiceFlow NLU that is part of that. And if you use the text action to the Dialog API for VoiceFlow, then it passes the text to the back end of the API, and it uses that VoiceFlow NLU to convert that into an intent with optional entities.
Okay.
So that is, you could, like, if you were writing a chatbot, you could just
pass it along.
Just pass all the text along and just let VoiceFlow's NLU handle it. That's also one less thing you have to worry about. The third action type that you can pass to the Dialog API on VoiceFlow is of type intent. That could have optional entities. So what that the way that that's understood is that if you pass or use that action type, then you've already resolved whatever it needs to on that end. And so when it hits the back end, it's just going to use that intent and those entities and not do anything with the built-in VoiceFlow NLU.
Excellent. Okay, so that all maps very neatly.
So that's on the input side. Now on the output side, you get back a JSON object that has various different block types. And part of the API configuration is that you can configure it to ignore certain block types. So basically, because there's different like flow control things and stuff that don't really have anything that's going to be part of an output that you would have to worry about. But there is a message type. There is an image type. I think it's actually a visual type. So those are the two main ones. So you can get back text, and all I had to do is map that to a output message on the Jovo site for a message. I check that message, see if it's got SSML in it. If it does have SSML, then I actually map it to a message speech type, and then I strip out the SSML and match it to a message text. I think it's just a text type on the object. So everything lines up just fine with Jovo on that. If it's a visual type, there is a type called a card on Alexa. So I create a card that wraps the image, and it will either, you can either render the card, or think even on Alexa platforms, it turns that card into a very basic APL implementation. And then the last part that you might have, because you might have multiple outputs in the one response coming back from VoiceFlow. If there is a tag that's an end node, then I have to set this flag that says, basically, I'm ending the session. I'm not leaving the microphone open anymore, and I'm ending the session. And so all of those mapped directly. It's just a little switch statement with some conditionals in it that maps what I get back from VoiceFlow to what it looks like in Jovo, and then the rest of it just works.
Oh, excellent. This all sounds very cool, very useful, and
Yeah.
pretty straightforward.
So yeah, so it's out there, it's available. We'll provide a link to that. And you know, if you've got any questions, you can contact me either via GitHub, which is where it will be hosted, or you can find me on social media or whatnot, and just ask some questions. Or it's open source, so if you've got some fixes for it, or have some ideas on something that you need to kind of solve your case, then we can figure out how to get that implemented.
Fantastic. And I'm sure we'll be talking about all of this stuff another time on Two Voice Devs.
Two Voice Devs. Take care.
Take care, Mark. Stay warm.
I will.